Hello, in this video I would like to discuss how to solve two logarithmic equations. The first one you see here, log to the base 2 of x plus 7 equals minus log to the base 2x plus 8 plus 1. So the idea is to collect all logs on one side. So that's why we add log to the base 2x plus 8 to left and right side, and we get log to the base 2x plus 7 plus log to the base 2x plus 8. On the right hand side you can have just one left from the top row. So when you have a sum of logarithm to the same base, and again I'm emphasizing that it should have the same base, like in this case 2. If they have different bases, then we cannot do it. So it will be log 1 log to the same base 2 of the product. That's the properties of logarithms that I posted for you. And this is the product property. So now we need to apply the definition of logarithm. Definition of logarithm is it's a degree you apply to the base to get logarithmic expression. So where is the degree? Degree is 1. We apply to the base 2 to get x plus 7 times x plus 8. In other ways, you can write down this top row in equivalent way. The product of x plus 7 and x plus 8 equals 2 to degree 1 or 2. So we have a quadratic equation. Let's open parentheses and have x plus squared plus 7x plus 8x, 15x plus 7 times 8, 56 equals to 2. And then once you solve this quadratic equation, you subtract 2, and then easy to solve by factoring. So two numbers whose product 54 and whose sum is 15 are 6 and 9, positive 6 and positive 9. So once you solve the quadratic equation, you get two solutions of the quadratic equation, not the logarithmic yet. Because to make sure that these numbers are solutions of logarithmic equation, you have to make sure that x plus 7 and x plus 8 are in the domain of the function log to the base 2 of x. In other words, x plus 7 greater than 0 and greater, not equal, and x plus 8 greater than 0. So make sure you see it's not equal, it's strictly greater. So when you plug in negative 6, both inequalities are true. Negative 6 plus 7, positive 1, greater than 0, negative 6 plus 8, positive 2. But when you plug in negative 9, it's enough for one inequality not to be true. In our case, both inequalities are false. So this equation, logarithmic equation, has only one solution, negative 6. Right. What do we do next? Next we're going to look at another example, and it will be another equation, which is log to the base 1/3 of x squared plus x minus log to the base 1/3 of x squared minus 1 equals to negative 1 equals to negative 1. So negative 1 here. Alright, let's see what we get here. So we have difference of two logarithms, so we can use the quotient rule of logarithms and write that it's log to the base 1/3. And again, I remind you, the base must be the same to apply the quotient rule, and we do have the same base 1/3. So of the quotient x squared plus x over x squared minus 1 equals negative 1. And again, once you have log equals to a number, you apply the definition of the logarithm. So that means that this is degree, you raise 1/3 to get logarithmic expression x squared plus x divided by x squared minus 1, which is 1/3 to degree negative 1. First of all, let's look at the 1/3 to degree negative 1. It will be 3. So we put here 3, and here we have the same expression. To solve this rational equation, you can multiply left and right side by x squared minus 1, and you get this equation. So what you get here will be x squared plus x. After you multiply left and right side of this equation by x squared minus 1, you get x squared plus x equals 3 times x squared minus 1, open parentheses, x squared plus x equals 3x squared minus 3. What next? Next we have a quadratic equation. We need to get 0. So I'm going to subtract x squared, and I'm going to subtract x from both sides. So what I have 3x squared minus x squared gives me 2x squared, right? So I'm going to put 2x squared. Then I have minus x minus 3 equals 0. Now I have to solve this quadratic equation. It's easy to solve by factoring, so we have 2x and x, and 3 is prime number, so we need to figure out which way will be correct for us. I think negative 3 here and positive 1. So 2x squared plus 2x minus 3x gives you negative x minus 3. And next step, we're going to solve each linear equation like we used to do when we solve a quadratic equation. So we have x plus 1 equals 0. So from here we get x equals 3/2, and from here we have x equals negative 1. So these all will be good. We'll look at the original equation, and remember we need to check the mean. The mean that x squared plus x for both numbers must be positive. So if you plug in 3/2 here, you get positive result. If you plug in 3/2 here, you get positive result. How about negative 1? If you plug in here negative 1, you get 0. 0 is not in the picture, so we don't need even check, but you get 0 here. So the answer for this equation only 1 3/2. So I hope it was helpful. Thank you for your time. Bye bye.